In this lesson, we'll discuss a great language feature in Objective-C called declared properties. The most common methods we write are accessors. Objects store data, and we need to give other objects the ability to read and possibly modify that data, but we don't want other objects to directly access our instance variables, and instead want to provide accessor methods so we can control how that data is accessed or changed. Now, luckily, Objective-C provides a great language level feature called declared properties that can automate this accessor generation for us. So it's much less verbose. Objects can store many properties, so manually writing getter setter code doesn't scale real well. And obviously, the more code that we write, the more opportunity there is to make a mistake. Declared properties are also highly configurable, so we really have complete control over how this code is generated. And we'll discuss this configuration shortly. Now, just like other methods, properties are declared in two parts. The property definition itself is defined in the class interface, and then we use this @synthesize statement in the implementation to tell the compiler to actually generate the implementation for us. So let's talk about the property declaration. Property declarations always take the basic form as illustrated in the orange text. So we begin with an @property, specify one or more attributes, specify the type, and then finally the property name. Now we have a number of attributes that describe how a property gets generated. The first of which is non-atomic. Properties by default are atomic to ensure atomicity of rights when operating in a multi-threaded environment. This effectively adds some locking behavior to the implementation of the setter. However, we can make a property non-atomic as well by using this non-atomic attribute. There's a performance benefit by not performing this locking, as read-writes frequently happen on the main thread. You'll commonly use this attribute. The next is read-only or read-write. By default, properties are read-write. This means when the compiler generates the code, it will create methods to both get and set a property. If we want to only generate the getter, we can specify read-only. We also have a number of attributes relating to the storage of a property. Specifically, these attributes impact how the setter method gets implemented. Let's talk through what these mean. The first is strong, and strong means that we want to keep what is considered a strong reference to this property. This is equivalent to explicitly retaining an object. We're essentially saying we want to own this reference, and as long as an instance of our object exists, we should maintain a strong reference to this property as well. This will extend the life of the property to be at least as long as our object's lifetime. The next is copy. This provides us with the same semantics as issuing a copy call on an object. We've already seen a few examples of why we'd want to do this. Most notably, your NSString properties will almost always be defined as copy. The next is weak. And weak means we'd like to hold a reference to this object as long as something else in our app is holding a reference to it as well. However, if all other references to it disappear, then our reference is set to nil. And this is an extremely useful attribute and is frequently used when we're working with delegate properties. We'll talk in great detail about delegates and delegation later in this course. And the last storage attribute is assign. This means we want to do a simple assignment. This is most frequently used when we're working with simple primitive types like ints, bools, and floats. We can also customize the naming of our generated accessors. By default, it will generate a getter with the same name as our property and a setter with the property name prefixed with the word set. The default naming conventions are typically what we want, so we don't use this attribute very frequently, but sometimes with booleans we'll use the is syntax for generating our getter. So in this particular case, I've got a property called favorite. But instead of relying on the default naming convention, our code may read better if we name this isFavorite. After we've declared a property in the header, we then use an @synthesize statement to tell the compiler to generate the actual implementation. By default, this generates an instance variable with the same name as the property itself. The preferred syntax these days is to explicitly declare the underlying instance variable, and that's what we're seeing in the second line of code. There are two primary reasons for doing this. The first is if we have a property and an instance variable named the same, it's very easy to mistakenly access the variable directly instead of using the property as you may have intended. By explicitly declaring the backing instance variable, or ivar, with an underscore, it makes it far less likely you would make this mistake. The second reason is due to some upcoming changes to the language itself. At some point in time, we won't need to explicitly use this @synthesize statement anymore, and the accessor generation will happen by default. This feature may not be available until iOS 6 is released, but the default behavior will be to create a property backed with an underscore prefixed ivar. To future-proof our code, it's a good idea to adopt this convention now. So let's switch back to our code and see these properties in action. So I'll switch over to my artist class. And we currently have a name and setName method to get and set the name attribute. Let's replace these with a single property definition. We'll say @property. I want to make this non-atomic. It's a string, so we'll say copy and give it the name. So we're able to replace both of our methods with a single property definition. I'll switch over to the implementation and scroll down to where I have these methods implemented. I can remove these altogether. Being able to delete code is always a good thing. And I will use this @synthesize statement to implement this property. So I'm explicitly declaring an instance variable of _name to back this property, which also means that I can delete this explicit definition of my instance variable. Hit Command B to compile, and everything compiles. If we run this application once again, we'll see that it continues to work as it always has. So all of our standard methods still work as we expect them to, our name and setName versions. Although the standard messaging syntax continues to work as it always has, properties also introduce this really convenient dot notation syntax into the language. So in this case where I'm retrieving the artist name, I can simply say artist.name, and this is the equivalent statement, but in a little more convenient, readable form. Just run this again, and we can see that still works as it always has. Likewise, on the setter side of things, we can use this dot notation syntax as well. I can replace this statement with rubbersole.name equals rubbersole. So that's a more convenient way of calling the setName method. So I can actually delete this line altogether. And I'll do the same thing down here as well. And I'll run the application once again. And there we go. It continues to work as it always has. I should point out this dot notation syntax is really just syntactic sugar. Although it might look like we're accessing that data explicitly, we're still actually doing so through the methods that are provided. So it's still happening through the name and setName methods. Let's add one additional property to our artist class. We'll give this object an ID. So we'll say property, non-atomic, and we'll do a simple assignment since we're going to use a primitive data type. We'll use an NSU integer, and we'll just call this artist ID. Switch over to the implementation. So we synthesize that property, compile, and switch back to our main app. So I can use this dot notation syntax once again. I can say artist.artistID equals 1. And this will set this value for me. And if I'd like to retrieve this value, I can use the property to retrieve that value as well. So let me rerun this once again. And now we have artist1, the Beatles. You now should understand declared properties. This feature provides a quick and easy way to generate accessors and also introduce a convenient dot notation syntax to the language to read and write property values. Properties are heavily used by the iOS frameworks, and we'll use these extensively in our own code as well, so you'll be quite familiar with this feature by the end of the course.